Well, guys, it was a good day. You know how I know it was a good day? Because I found this on one of my boards. It means I'm making some progress. You're welcome. Alright guys, so last one for the chapter. Again, we're going to talk about graphing linear and absolute value inequalities. Okay, so again, now you're going to need to remember the forms y equals mx plus b for the lines, and then remember that the parent graph for the absolute value is y equals absolute value of x. And again, now we're gonna add a couple different things in it that's gonna make it into more of an inequality type thing, where a lot of the same rules that you guys remember from before are still gonna apply. So get excited. Here we go. Linear equality is exactly like a linear equation, only it has an inequality symbol. Okay, and again, like I said, it's related to an equation, or to a linear equation. Okay, you guys really don't need to write this down if you don't want to. The boundary line. Okay, this is really important to get down. You definitely want to write this down. Okay, so again, it says that the linear equation, again, is a boundary for this whole, because again, like when we're talking about like a regular one, like if I said x is greater than 3, again, we would use like an open circle or like in this case, and then you would say, okay, it's greater, and that would be our answer. Okay, now we're going to do the same thing, except we're going to use lines for that, and the line itself is going to be like kind of like the same thing as like the open and closed circle. All right, so anyway, let me erase that, get it out of here. Again, if you have a less than or a greater than sign, it's going to be a dotted line. Okay, and if you have less than or greater than, or less than or equal to, or greater than or equal to, it will be a solid line, as if you needed a reminder of what a dotted and solid line look like. You're welcome. Alright, so here's first example. Again, guys, we're always going to be following the y equals mx plus b. Alright, so again, you start at your y-intercept. So you see we got -1, so you're going to make a mark there. Okay, and then I've got my slope is -3 over 1. So I'm going to go down 3, 1, 2, 3, and over 1 unit. Now, after you do that, again, you don't want to just draw your line again, because that's going to kind of complicate things. You look here, we see a less than sign. That means it's going to be a dotted line. If there's no equal bar, it's just going to be dotted. Okay, so I'm going to do my best here. Okay, there's my dotted line. Now, the last part is shading. It's really important. Okay, so for the shading, what you're going to do is you're also going to look to this sign. Now it says less than. I want you to take your pen, and I want you to put it on the y-intercept. Okay, so again, it says less than, so which way are the numbers less? Up or down? Okay, so again, in this case, you see it's down, so that means that we're going to shade this whole side. Okay, and again, I want you to just use these little flares. Don't color it in. You can kind of make them longer if you want. But again, the little flares are what's going to help you. Again, once we start doing systems, it'll make a lot more sense why we're doing it. All right, next one. Again, this one is not in. It's not in y equals mx plus b form. This one's in the standard form. I want to go ahead and I want to solve for y here. So I'm going to again, it's positive x, so I'm going to subtract x from both sides. So now it'll be -2y is less than -x plus 4. And then last step is to divide by -2. Should hear alarm bells going off in your head. Okay, this crosses out. Now again, y, I'm dividing by a negative. Anytime that happens, you got to flip the sign. So it's going to be y is greater than. Negative over negative is a positive. Okay, this is just 1/2. So positive 1/2 x. And then 4 divided by -2 is -2. So let's go ahead and graph it. So we will start at -2 right here. And I'm going to go up 1 and over 2. And then again, now you look at your inequality symbol. In this case, it's greater than, so it's going to be dotted again. Make sure you can extend your lines to the edges of your graph. And then again, we look to the inequality again. This time it's greater than. Alright, so again, you put your pencil on the y-intercept. Where are the numbers greater, up or down? Well, it's always going to be greater than up. So again, we can go ahead and shade up. Easy enough, right? Let's keep going. This one's pretty standard. Again, you're going to start at +2. Slope is negative, so you go down 3 and over 5. So right here. And you see that finally I have an equal bar. This is less than or equal to. So this is going to be a solid line. I'm going to do my best here. I don't know if I'll really be able to. That's not too bad. Look at that. Okay, and then continue this way. Could have been way worse. All right, so now again, that's our solid line, and it's less than, so you're going to shade down. Now again, the reason I have you guys put your pencil on the y-intercept is that sometimes the graph is going to look like this, and your line is going to be like really steep, and it's not going to be as easy to tell which side to shade on. Okay, so you want to put your pencil on the y-intercept, and then wherever that is, that's where you're going to shade, or whichever side the up or down is going to be, that's where you shade. So we might see one later on in the video. So let's keep going. All right, so this one is y is less than 4. Again, these are the special lines, okay, that everybody forgets how to do. So again, think of it as when there's no x, the slope is 0. Okay, so again, y is less than 4. Okay, so here is 4. Okay, now again, this means that y is always less than 4. So it doesn't matter what x is going to equal, y is always less. So again, x could equal 1, y is going to be less than 4. -1, less than 4. Okay, so you guys can see that it's going to be a horizontal line, and again, it's a not equal to, so it's going to be dotted. So I'm just going to make a dotted line right here. Alright, and then it's less than, so again, we'll put our pencil on the y-intercept. Numbers are less when it's down. Okay, so I'll shade down, just like that. Perfect. Keep going. And let's see what we got. Again, so again, this is an x is greater than or equal to -2. What you want to remember with this one, guys, is that, again, if it's y equals, it's always horizontal. If it's x equals, it's always vertical. So you're going to go to -2 on the x. And again, no matter what y equals, x is always -2. So it's going to be a vertical line up and down like that. And you see there's an equal bar, so it is going to be solid. Something like that, and it says greater than. Now make sure, just think of a regular number line for this one, because again, you can just start on the -2, and then which way are the numbers greater, left or right? Okay, well, it's always on a regular number line, it's always right. You can just shade that way. All right, let's this is a little bit of a different example, and again, it says example 5 again. I don't know why it does that. I apologize. Counting's hard, guys. Okay, just get off my back. Okay, this one is not about graphing. This is just about an inequality in general. So okay, so it says one tutoring company helps students who have a combined SAT, verbal and math of 900 or less, math score, or verbal and math score. Of 900 or less. So it says write an inequality to represent the situation if x equals verbal and y equals math. So again, there's two different scores in the SAT. So what you're going to do is you're going to take it. Okay, you have to add them up and see what they're less than. Okay, so again, it's something less than 900. Okay, so 900 or less. So again, you have to think about it. Okay, so you know it's going to be less than. So now you have to say, okay, if I got a 900, are they going to help me? Okay, so it says, okay, combined SAT of 900 or less. So again, it looks like if I got a 900, they would still help me. So x plus y is less than or equal to 900. Okay, and then the last one, it says, does a student with a verbal score of 480 and a math score of 410 fit the company's guidelines? All right, so again, all you're going to do is just plug them in and see if it gives you a true statement. Okay, so if you plug in plug in 480, it'll be 480 plus 410 is less than or equal to 900, and 400, so that's going to be 890 is less than or equal to 900, which is true. So yes, they would help you. All right, now let's move on to absolute value. Again, the same rules apply, except we're just going to graph them a little bit differently. So again, this one, again, the vertex is at 0, -2. Again, you see that from the parent graph and like all the transformations and stuff we talked about, that this is just going down 2 units. So again, I'm just going to put the vertex at 0, -2 right here, and then the slope is 1, and I'll go up 1 over 1, and then up 1 the other way over 1 to make my V. All right, now we got to figure out where to shade. Oh, and I'm sorry, guys. I did it right without even talking about it. Okay, this is greater than or equal to. So again, it is going to be a solid line. Okay, if it had been just greater than, we would have had to do a dotted line. So anyway, now we got to figure out where to shade. It says greater than, so again, you look and see, put your pencil on the vertex. The numbers are greater up, so I'm going to shade up here. There you go. Let's go. Let's go again. Next one, greater than or equal to absolute value of x minus 4 plus 1. So again, vertex, remember inside's always opposite, so this one's vertex is going to be at 4 comma 1, and we will go ahead and put it there. So that's 4 comma 1 right here, and the slope again is 1, so you go up 1 over 1, up 1 over 1. Again, it is greater than or equal to, so I can draw a solid line for both of my sides, and greater than again, so I will just go ahead and shade up. Just like that. Now again, I could extend my lines. Okay, if we extended this, again, you would want to make sure you're shading that way too. Okay, as long as I can understand what you were trying to do, I think I'd be good. All right, and guys, I'm all done. All right, have a good one. I'll see you tomorrow.